we're going to look at examples with tape diagrams for ratios. Our first problem is a lemonade problem. In this one, it says for every 4 parts of water, there are 3 parts of lemon juice added. If there are 35 cups of lemonade altogether, how much water and lemon juice are needed? What we can do is look at what we know. And what we know is that there's 4 parts of water. I highlighted it in the blue. So I'm going to show this by using 4 squares. So the 4 squares are blue to correspond to water being blue. 1, 2, 3, and 4. We also know that there's 3 parts of lemon juice. So I'm going to use 3 squares for the lemon juice. We know together I have 7 squares, the sum of 4 and 3. I also know that there are 35 cups of lemonade altogether. So here we have 7 squares altogether, and we want 35 cups altogether. So we can find the quotient of 35 and 7, which is 5. That means that each of the squares is equivalent to 5. So for the water, it's 5 multiplied by the 4, since there are 4 squares, or 20. For the lemon juice, it's 5 multiplied by 3, for the 3 squares, or 15. So for 35 cups of lemonade, you would need 20 cups of water and 15 cups of lemon juice. Now let's do a little ratio review. If we look at the lemonade problem that we were just solving using ratios, we can write it this way. For every 4 parts of water, there are 3 parts of lemon juice added. We would write 4 to 3. That's the way we say it, 4 to 3. We don't say colon, but we use the colon to show that it is a ratio. For the solution, we said that it was 20 cups of water for 15 cups of lemon juice, so I could write it 20 to 15. Remember that order is important. If you wrote the 15 first, that would look like the 15 is the water, and then the 20 is the cups of lemon juice. So the way that it is written in the problem is the way that you would write it as the ratio. Let's look at another problem. In this one, Kate shares her cookies with Sammy and Rachel at a ratio of 2 to 3 to 1. There are 24 cookies in total, so how many cookies does each person get? So we can use color to show this, Kate being red, Sammy being green, and Rachel being blue, and they correspond 2, 3, and 1. Remember, we write the ratio in the order that it appears in the problem. So Kate is first, Sammy is second, and Rachel is third. What I did was I showed the 2 as 2 squares for Kate, 3 squares for Sammy, and 1 square for Rachel. We know that there are 24 cookies in all, and I see here that I have 6 squares. So the quotient of 24 and 6 is 4. Therefore, each square represents 4. So 8 for Kate, 12 for Sammy, and 4 for Rachel. So Kate got 8 cookies, Sammy got 12, and Rachel only got 4 cookies. Here's our last problem, and this one is a little different. The ratio of the number of Julie's stickers to the number of Andy's stickers was 2 to 5. After Julie bought another 40 stickers, she had 2 times as many stickers as Andy. How many stickers did Andy have? So we're going to look at Julie and Andy as a ratio of 2 to 5. So Julie is in the red and Andy is in the blue. And again, it's in the order. Julie was first, so Julie is 2. Andy is second, so Andy is 5. With tape diagrams, Julie has 2 squares representing the 2, and Andy has 5 squares representing the 5. Now we know that after Julie bought another 40 stickers, she had 2 times as many stickers as Andy. Well, right now Andy has 5. So 2 times as many would be another 5 or 10. But she currently only has 2. So she needs 10 total or 8 more squares. So I showed those 8 additional squares as green squares. We know that after Julie bought another 40 stickers, so that means that these green squares are what she bought. This was the 2 times as many. and we know that it is equivalent to 40 because it says 40 stickers. There are 8 squares, and if the total of the squares is 40, then we can divide 40 divided by 8 so that each square is equivalent to 5. Again, it says how many stickers did Andy have? So Andy had 5 plus 5 plus 5 plus 5 plus 5, or the product of 5 and 5, which is he had 25 stickers. I hope this helps. When you visually look at ratios, I think it makes more sense, and using color I think also helps. So try those strategies and it'll make working with ratios not only easier but more fun.